Hello, everybody, and thank you for joining in on our ToloTalks. My name is Kenny Green. I'm an applications engineer at Tolomatic, and today we are going to be talking about rod-style electric actuators. In our previous ToloTalks, we talked about actuator basics and rodless style, and today we're going to be covering the first part of rod-style electric actuators. So Tolomatic has a very wide range of electric rod-style actuators. We have particularly 4 families of actuators. We have our IMA series, which is an integrated series, has motor integrated into the actuator itself. We have our RSA and GSA series, which are more of a traditional workhorse actuator. We have our ERD series, which is stainless steel compatible and in the smaller sizes and economic design. And then we have our extreme high force series, which is the RSX series. Today, I'm going to be talking about the RSA and GSA series and the RSX series. The IMA and ERD series will be covered on the next ToloTalk. To give you the highlights, these actuators have force ranges up to 50,000 pounds of force, stroke lengths up to 60 inches, have a variety of ball and screw options, several different types of mounting, and are typically made of aluminum and stainless steel housings. When selecting a rod-style actuator, there are some important criteria to keep in mind. These include the environment that the actuator will be operating in, whether it's a washdown rated environment, outside, the dusty and dirty environment. It could be a lumber mill where you got cold and heat, extreme cold and heat, or it could be a clean room environment. All these factor into what family of actuator you'll be looking at using. Another couple of criteria are speed, load, and force. And all these come into play when you put in the duty cycle of the actuator. So you can have a high speed, but at low force and low load, or you can have a high force, but typically you would be operating those at a low speed. And when you combine those, you get the duty cycle of the actuator itself. An important thing to keep in mind here is that load and force are actually different. Load is the physical load that is attached to the actuator itself. So think of a weight that the actuator is lifting and lowering or pushing and pulling, whereas force is the actual force that the actuator is going to be pushing against. Think of a spring compressing a spring, as opposed to lifting and pushing and pulling a spring across a surface. Another thing to consider is life, if you need the actuator to last millions of cycles or just thousands of cycles. And design footprint, how big of a space do you have to put this actuator in, and what space constraints are you looking at? Additional features are also an important part of this, whether you need purge ports, different rod end options, what type of mounting options, etc. Again, you can't have the maximum speed and maximum force on an actuator at the same time, and so you need to take every part of that into consideration. So we're going to start off with the RSA and GSA series. A little bit of points about them, and we'll be covering the highlights now. So the RSA series, or family, is broken up into 6 different sizes that are split into 2 different series. We have the standard torque series, which encompasses all 6 sizes. That series has a force range up to 4,000 pounds, strokes up to 60 inches, and speeds up to 62 inches a second. The high torque series encompasses the larger 4 sizes of the actuator, the RSA 24 through 64. The high torque series allows for a higher force capability in the actuator. This comes from being able to allow roller screws as an option, and they have a different bearing and component design that allows for higher torque motors and higher force applications. These also this roller screw option in the HT series also allows for a longer life within the actuator, and we'll cover a little bit of screw basics later on in the conversation. Importantly, also all of these actuators encompass our your motor here compatibility, And what this allows you to do is mount most third-party motors onto these actuators using our Your Motor Here program. You simply find the actuator you want, search up the code for the motor brand and series, and the actuator will be built with a mount specific for the motor. These actuators are ideal choices for complex fluid power systems. So if you're doing hydraulic or pneumatic replacements, these actuators are great replacements because they fit very similarly to a hydraulic actuator and allow you to replace all the complex components that you typically find in a hydraulic system with a simple motor and drive setup. The GSA series of actuator is very similar to the RSA ST actuator series, except the only difference is that the GSA is guided. So it is available in the 4 smaller sizes of actuator, the 12 through 32 sizes. And these are particularly used in applications where the load of the application isn't externally guided, and the actuator itself will act as the guide for the load. So these work in great situations where you're using, for example, gantry systems where the actuator itself acts as the guide and you don't have to have complex external guides guiding the loads. That way you can have a compact solution for your application. One thing to note at this point is that because of the guide on this actuator, the guide is typically used as the mounting surface for this actuator, so it doesn't have the same amount of mounting options as the RSA series. So let's dig a little deeper into the RSA series and how it's built. First part to note is that the rod of the actuator is the part that moves in and out. So the thrust rod is attached to the ball nut or the nut of the actuator itself. What this allows you to do is when the screw of this nut is rotated, that allows the nut of the actuator to traverse over the screw and allows the thrust rod to move in and out. This screw is then supported by a bearing in the back of the actuator and then is driven by the motor. With this cut out, the motor is placed in the actuator in a reverse parallel format. What this means is that the screw is driven by a pulley, which goes to a belt and goes to another pulley attached to the motor itself. Another way of driving the actuator is to have a direct inline connection. And with that, the motor is placed directly behind the actuator and it is coupled together with a coupler system. A few key features of the RSA to note is that we have high capability thrust bearings in the rear part of these actuators. On the on the nut itself, we have our internal anti-rotate design. This encompasses 4 pucks that are built internal to the nut and allow prevent the nut from rotating the thrust rod. So this allows your thrust rod to go in and out without any external guides to prevent it from rotating. Another thing to note is our lubrication port on the actuator. This is available on the HT series. And then IP67 is the ingress capability of this actuator. It's an option available on some of the sizes. So there are 4 different types of screw options that are available with these actuators. There is a solid nut, a ball nut, a roller nut, and a bronze nut. The solid nut allows for is a quieter option and a low cost option. These are typically used in low force, low life applications, and it does allow for a little bit of resistance against backdriving. The ball nut is the main nut of choice for medium load capabilities and medium force requirements. These offer high speed and efficiency and a decent life on the actuator. Roller nuts are the nut of choice for high force and long life applications. These nuts induce rollers instead of balls that travel throughout the nut itself and have a extremely long life capability and are used explicitly in our high force actuators. And then finally, bronze nuts are a Acme screw nut that, because of their design, allows for no back driving in the actuator whatsoever. So you can move the actuator into position, and whatever load you put onto the end of that thrust rod will not back drive the actuator and keep it from, and you can, at that point, turn off your motor and the actuator will stay in position until the motor moves the actuator again. So we'll go over some highlights of the RSA and some options that are available with it. At this point, I wanted to note that I will be taking questions at the end of the presentation. So you can hold your questions till then, and then I'll answer a few questions then. So with the RSA actuator, like I said, there are 3 main screw choices that you can have with it. We do allow roller screws in the actuator. There's the standard internal anti-rotate design that I went over earlier. We have year motor here capability with our reverse parallel setup and the inline setup, as you can see on the screen, and a variety of motor mounting options with that. Also, part of the RSA series is that we have configurable stroke lengths. So you specify the stroke length that you want, and we build the actuator to that exact stroke length. On the right side, you can see a variety of options that are available with the RSA actuator series. These include mounting options, such as flanges and foot mounts, and pivoting options, such as trunnions and clevises. On top of that, you have several different rod end options. So depending on what application you're in and what your application requirements are, we typically have an option for that. Some of you are thinking at this point, why would you want to upsize to an RSA HT as opposed to the RSA standard torque? Well, the HT upsizing allows you to have the roller screw option. And what this allows is for a longer life and higher force capability. The higher force capability comes from a different bearing design and torque transmission. But the couplers, they're built differently than the standard torque and allows for these higher torque, higher force applications. This also allows for expanded motor mounting capabilities. This option allows for keyed motors and gearboxes. So you can have a gearbox using a reverse parallel motor mount on the high torque series, but in the standard torque series, because of limitations within the bearing design and the coupler and the force capability of the actuator, you can't have gearboxes on an RP. So on the right side, you can see some highlights for reasons to switch over from a standard torque series to a high torque series. Let's go over some practical applications for these RSAs. This is an application example that we have worked with a customer on. They needed actuators to work in their specialized wind tunnel, and the actuators needed to move the fins in the wind tunnel so that it could change the direction the wind was applying against sports cars. This was a complex situation. They needed several actuators that were going to be reliable and dependable and last a long time. They required servo motors for mounting. And in this particular application, they had actually already purchased the servo motors. And so we were working backwards from going from motors and sizing an actuator to fit those motors and the application at the same time. There was a lot of back and forth with this customer, doing different sizings and working with them on motors. And because of our capability of communication with the customer, we were able to size up an RSA actuator for this application and work with them on setting it up in the system. What resulted from this was that the customer ended up purchasing several RSA 24 actuators with roller screws. The roller screw technology allowed them to have a long, reliable life over ball screws and provided them to have the force capability that they needed to turn these fins. Because of the amount of wind that is blowing through past these fins, they actually needed a high force capability to position them in place and keep them where they needed to be. Because ToloTalks manufactures their own roller screws, this kept the cost low and the quality high. Plus, with our Your Motor Here program, we were able to integrate the customer's motor into the RSA actuator seamlessly, and which provided an easy, fluid design for the customer. Through our process of going back and forth, we were able to provide a solution for this customer, and the customer was happily able to use it in their design. Another example of the RSA series in real-life applications is a walking beam application for a pork producer, a pork processing company. Walking beam is the beam that has the pork carcasses hanging from the ceiling, and that as they move across, they had a hydraulic unit that would move pork carcasses across the walking beam. The concern of theirs was contamination from leaking hydraulic fluid. If you had a spill or a leak through the hydraulic system, it would get on the pork and you would ruin the entire batch of pork at the time. So they needed a new way of moving these pork carcasses that didn't require hydraulic. So they didn't have any previous experience with electric actuator technology. They contacted ToloTalks, and ToloTalks, through years of going back and forth with them, was able to give them a solution for their application. This solution ended up being several of our RSA 50 HT actuators. The reason they went with us is because the actuators had the high enough force capability that eliminated the risk of hydraulic leaks and contamination and reduced maintenance and operating costs. The actuator was modified so that it could fit within the same footprint of the hydraulic cylinder that they had, which was happy for the customer because it allowed them not to have to rework their system. And because of our fast response and multiple customer requests, we were able to go back and forth with the customer to find a solution for them that worked best for them. Plus, with our Your Motor Here program, they were able to fit the Cole Morgan motors that they wanted to the actuator and didn't have to, and weren't forced to go to a different motor brand that they weren't familiar with. Needless to say, this customer was very happy with the transition, and they have moved from hydraulic to electric actuators. Here are just a couple highlights of our actuators in practical applications. They are used in a variety of applications, from sawmills, tensioners, metalworking, security barriers, and even vehicle simulators. The amount of applications that you can use an RSA actuator in are almost endless. And every time you see a hydraulic actuator somewhere, you can almost always say that you can replace it with an electric actuator. Okay, so now let's move on to our RSX series. The RSX series is an extreme high force solution for hydraulic replacement application. This is the big brother of the RSA series. You go from maximum force ranges of 14,000 pounds to maximum force ranges of 50,000 pounds with these actuators. So let's dig into them a little bit more. So here's an overview of how the RSX actuator is designed. It's very similar to how the RSA actuators are designed, but there are some key component differences. For one, the RSX actuator has several bearings in the back that allow for high force in both the push and pull capability. Because of the largeness of the actuator, we actually have a lube access port on the side of the actuator. This allows you to take off the cap and reach in and grease this roller screw directly. With the RSX actuator series, because it's such a high force actuator series, it only uses roller screw technology. This allows for heavy duty, high force, but also allows for long life lasting. There are also some key design changes in the way it operates, and a little bit different design change on the coupler system and motor mount capability in the back. This allows for larger motors larger gearboxes to mount to the actuator itself. Within the RSX series, there are 3 sizes and 4 different models. There is the RSX 80, RSX 96, which there's a spin-off of, which is, we have the RSX 96T, which is a press model. And then coming soon, we have the RSX 128. And the 128 will allow us to go from a 40,000 pound capacity to a 50,000 pound capacity, in both pull and push. In each of these actuators, we have our ToloTalks roller screw design in them. They are built in, the roller screws are ground and built in ToloTalks facilities. And so the whole actuator is built in the same facility and tested there. Configurable stroke lengths up to 35 inches. And again, these have our Your Motor Here compatibility. So you go in, you size the actuator, and you can choose the motor you want to put on the actuator, and it will standardly fit. And with that, we're allowed to have 4-week lead times on all standard RSX actuators. Additionally, these actuators have IP67 protection ratings as an option for them. The press version of the RSX 96 is a bit different. This version is specifically designed for pressing, punching, piercing, clinching, riveting, and more applications like that. These are specifically designed actuators for replacements of hydraulic presses. The 40,000 pound capability of this actuator is only in the extend direction. So when the actuator is extending down to press something into place, so if everything in the actuator is in tension or in compression, that's where you have your 40,000 pound capability. But when it's pulling something, it only has a 15,000 pound capability. This actuator has some internal design changes from the regular RSX 96 that allows for these force capabilities. And with this, it allows for a good actuator with a smaller package to be able to reach a higher force capability when pressing an application. Again, this one has our planetary roller screws, configurable stroke lengths up to a little over 17 inches, and Your Motor Here capability with motor frame sizes up to 190 millimeters. Again, these actuators have fast delivery as well, with a 4 to 5 week lead time typically. On top of our standard RSX series, we also do customization. One of these options is a food grade white epoxy paint option. In this actuator, in this version of the RSX, we have a IP67 rating. Many of the components are switched out and made with stainless steel instead of regular steel. And all the components, all the aluminum components or components that can't be made out of stainless steel are white painted. This allows these actuators to be used in high force food rated applications. This model isn't a standard option, but can be ordered as a modified option to all of our RSX series and sizes. So let's talk about real world application with these heavy duty massive actuators. One application that we worked with is a large OEM of automotive brakes. This was a tier 1 major automotive end user, and they needed press assemblies for assembling automotive brake pushing in the bushing sleeve into the brake system. Challenge was the customer wanted extremely long life and durability, and they wanted to go away from hydraulic actuators. They wanted a complete electric solution, and they wanted one supplier to provide all their actuator needs. They needed to be easily integrated and for a variety of applications, from pressing, parts transfer, overhead transfer, and more. With this particular application, the customer had had previous experience with ToloTalks and liked the actuator that they had purchased. And so on their next design change within their assembly lines, they wanted to use ToloTalks exclusively because of the good experience they had had with them in the past. So with this application, we came up with a variety of solutions for all their actuator needs. We had the customer come to ToloTalks. We worked directly with their engineers in sizing and specifying actuators for all their different applications. Our fast responses allowed for multiple issues and requests to be fixed and answered quickly. And what they ended up doing was purchasing a large variety of actuators, but many of these actuators were RSX actuators. Main benefits of the RSX actuator was that they had longest possible life with extreme durability. The customer purposely purchased oversized actuators because they wanted the long life. The wide range of our rod and rodless products allowed the customer to work with just one supplier. They didn't have to source out multiple actuators from multiple different suppliers. They were all able to source all their needs from one company. And our Your Motor Here program allowed a variety of mounting range options for all the actuators that they were purchasing, including the RSX. Needless to say, the customer was able to implement our actuators into 5 production lines and are very happy with the outcome of these applications. Another application that we use these RSX actuators in is a metal forming and bending application. This was used in a company that made steel fencing primarily for livestock industry. They wanted to get away from hydraulic actuators, but didn't really know about how to go about that because this was the first time they were moving away from hydraulic and into the electric realm. They didn't have a whole lot of experience on electric actuators, and they wanted one supplier to help provide the actuator requirements, but also talk them through how to go about going from a hydraulic to an electric change. The solution we came up with was several actuators used in their metal bending machine. We had to go through regular meetings with the customer to review and design their application and their design so that we can size up the ideal actuator for their application. In this case, it ended up being several RSX actuators because the RSX actuator was the only actuator with a high enough force to do the metal bending requirements that they were needed. They were working with large pieces of fixed tubing steel, and they needed a high force actuator that was going to be able to do several bends, several million bends over the life of it, and still be able to have the force requirement needed to bend it. On top of the RSX actuators, we've provided a variety of our other actuator series to help with the positioning and moving and drilling hole operations. And again, our Your Motor Here program allowed the customer to mount a range of Nidec control technique servo motors, which you can see in the pictures attached to our actuators. This allowed for seamless motor integration and allowed for a quick lead time and turnaround. Customer is very happy with this application. It allowed them to seamlessly transfer from hydraulic to electric and still allowed them to output the parts that they needed. So this is a quick breakdown of the value of switching from electric actuator system from hydraulic. In one of our later ToloTalks, we'll go into this in more detail, but this is a quick slide of just a quick bullet points of the capability of electric actuators. You have precise precision control, speed and acceleration, infinite motion control, which you don't get with electric, your accuracy, you eliminate multiple components. So you go from a hydraulic system that has heat exchangers, pumps, filters, valves, gauges, controllers, to an electric actuator that has actuator, motor, and drive, and the cabling that goes between it. So it allows for a less messy and more energy efficient operation with honestly little to no maintenance. With hydraulic systems, you're typically maintaining them all the time, looking for leaks. With the electric actuator, once it's up and running, it's usually good to go, except for maybe a few times you need to grease it. Also, the operation is much quieter. Electric cylinders and pumps can get very noisy, but electric actuators are typically less noisy.